Hi everyone, this is Gennaro from 4-Week MBA, and this is a new format that I'm testing. This is a sort of a presentation that I gave into a broader context of the business engineering curriculum for a private workshop more than a year back, but I think this is still quite relevant. So I wanted to share just a part related to the AI landscape. I hope that you like the format and bear with me. Those are tests on new formats that I'm doing. If you do like it, please reply back to the newsletter so that I make sure that I can keep adding value and doing relevant stuff. We don't want to waste each other time pretty much. But just to get straight to the point, I want to do like a snapshot of the AI ecosystem as it is right now and where I think we're going next by looking at the current paradigm of the AI ecosystem. Pretty much just so that we understand where we are right now. The current AI ecosystem from a commercial standpoint really exploded with the launch of ChatGPT at the end of November 2022. Of course, for anyone who has been working in the AI industry like myself in the past years, you know that things didn't just happen in 2022. Actually, probably the year where things really exploded was probably 2020 with the launch of GPT-2, which was, I guess, the first real interesting application that we saw with the release of a model, of a GPT model that really made a lot of sense from a commercial standpoint again. And of course, we can go back also to the whole history of OpenAI, but I'll leave it up this history for another time, and I'll give some glimpse into that as well. But right now, it's interesting because we need to look at the current AI landscape by looking at two kind of paradigms that have changed the whole landscape and really created a new paradigm of software paradigm, as I like to call it. But this software paradigm was, first of all, possible thanks to a new hardware paradigm. Now, this might sound trivial for some of you, but for many, might be still something that is critical to understand. So I'll spend like a minute on that and then I'll move forward. But pretty much just to understand what makes us really, what made us get here in terms of hardware is the fact that over the last decade or like 15 years, we had companies that managed to specialize on building a powerful GPU infrastructures that could handle parallel computing, which is what really enabled the building up of what we call today AI supercomputers that sit inside companies like Microsoft. So within the Azure department, so the cloud department of Microsoft, you find a supercomputer, an AI supercomputer, which is made, if I'm not mistaken, of hundreds, if not thousands right now, of GPUs from companies like NVIDIA. And this is really the starting point that enables companies like OpenAI to really perform the so-called pre-training phase, which is really a key element of the whole thing, because through pre-training, you can achieve a generalized AI large language model that then you can fine-tune for specific tasks. But it all starts from this new hardware paradigm, which again, started thanks to the fact that finally we could have available like a huge amount of GPUs that could be used for this. Then we can also digress a little bit, go back and see why did we have as well so many GPUs. And we can find out that, for instance, companies like NVIDIA initially were focused on gaming, and also that a lot of GPU computing power also came from the fact that we had the previous bubble previously to AI, which was like crypto, where as well those GPUs were useful for mining crypto. And then it might be that many that work in AI found some of those GPUs on the cheap, thanks to the fact that the bubble burst, the crypto bubble burst in the 2020s. Anyhow, that's the hardware paradigm, which is critical to make sure that we can build a pre-training, so we can perform a pre-training of an AI model in the first place. And the pre-training stage is quite critical. And as I'm noting here, then once you have the pre-training, that's how you start. And after the pre-training, you have the fine-tuning, where you go from a generalized model to having a more specialized model, like, for instance, GPT-3 or GPT-4. And then from there, to transform that into what we know today as GPT, actually, you need to have another sort of model on top of it, which is Instruct GPT, which is more like a sort of reinforcement learning with human feedback, that enables those models to become quite good also at specific tasks, and especially to prevent them to be many of the drawbacks that we have with those generalized models. And this is really the underlying infrastructure that enables us to go and look at the current business paradigm. That is going to be at the end of this lecture, really. But really, how did we get here? And the interesting part is that this journey of AI is a long one, and we can go back to the late 90s, mid 90s, when two PhD students, which were Sergey Brin and Larry Page, the co-founders of Google, actually had this idea of creating an architecture to indexing the growing amount of pages on the web, which really was the foundation of Google. Now, Google has known since the foundation of, or actually even before Google was started, PhDs like Brin and Page, they were also quite aware of the potential ability of AI and neural networks, but at the time it was quite early. But they knew that one day what would have made Google non-relevant, or actually transition Google to what it was supposed to become since the onset, was an AI that would manage to give answer to users, not only to give answers to users, but also to provide an answer even before the user could ask for it. So an AI that could work in a proactive way to give a specific answer to the user even before this would get asked by the user. So this would be the final genesis of Google. And Page and Brin, they knew that, and that's where they were investing a lot of resources for Google. That's why when we go in 2017, we have a paper called "Attention is All You Need," which is considered probably among the foundational papers that enabled this new AI revolution, because finally we had an architecture called a transformer architecture, which enabled to really perform a sort of a pre-training on top of a very powerful chip like the GPU, and thus really making the best of it in terms of giving it a huge amount of data to enable the AI to learn many things. Of course, we can argue what the AI is doing at that point, and we know that the transformer-based architecture does something extremely simple, which is at the end of the day, the large language model is doing a token-to-token prediction, text-to-text prediction, but then it's still an open question of what's going on at scale when a large language model has a huge amount of data. One of the key elements of this new paradigm, new hardware and software paradigm, is that finally we would be able to fetch on top of these huge GPU infrastructure, transformer architecture, where you could give it a huge amount of data, set hyperparameters, but also a huge amount of parameters that the model could use and that could be adjusted to make sure that the large language model, could get better and better in token-to-token prediction, and also to give it examples that would enable it to actually learn. initially in an unsupervised manner. And this is one of the key revolutions from the software perspective. But then later on, by showing it a few key examples that would make it extremely relevant. So this is a reminder that the current AI landscape, or what we call AI today, is really like a subset of the AI industry, where really we have a deep learning, and within that we have the family of machine learning neural networks. That again is not something new. It's something that has come out already by the 50s or 60s with the first attempt to make neural networks successful with, for instance, a first kind of a neural net, which was, I think, called the perceptron, which was a neural net, I think, with a single layer and a few neurons. And again, those are called neural networks because they are inspired by the brain, a human brain, but fundamentally they are quite different for what we know so far, meaning that what's going on inside a neural net with hundreds of layers. So take into account that the reason why finally, after decades of the first perceptron, we managed to build a successful, large language model like GPT series and all the others that came out. It's because finally we could stack on top of each other hundreds of layers of those neural networks, where you have, for instance, the input of one layer, the output of one layer, which becomes the input of the other layer, and so on and so forth. And things stacks up in a way that sort of reverberate or sort of expand in the whole network. And we reach the amount of complexity which we cannot know for sure about what's going on. And that's also one of the interesting aspects of generalized large language model. But it's also what made this architecture and family of neural networks work. Because again, this is not something new. It's something that was speculated for the first time many decades back in the 50s or in the 60s. But the way and the reason why it worked because we finally had an hardware infrastructure capable of supporting a software paradigm like the transformer-based architecture that could handle that sort of complexity. And whether this will turn out to be the architecture that makes us do many more things, we don't know, and we cannot know for sure. But how does the hardware, the simplest part of the hardware looks like? You can see here, this is a TPU from Google. It's a specialized chip that Google designs to actually just train its own AI. And Google has been always impressive on that, because already 10 years back, Google was working on this stuff at multiple levels and integrating this into the search at scale. For instance, things like feature snippets, where you got the direct answer on Google about questions that users were asking at scale, would employ some parts of the AI that Google had built into its own search infrastructure. And here instead, you got the GPU of NVIDIA, which has become really the AI 100, which has become one of the most important elements to enable this AI revolution. And here an example of how the AI supercomputer within Google, made of probably hundreds of TPUs, looks like. But this to give you a sense of what's making the AI revolution possible from a software perspective, because we working on the web forget that what makes this possible is not just something that comes from something abstract, but it's this huge amount of hardware infrastructure. Without that, we would not have any of the AI revolution that is going on right now. So how does the whole thing work? And again, just a bit technical, but just to have an understanding, you start from the hardware paradigm with your AI supercomputer made of hundreds, now going toward thousands of GPUs, where you're able to pre-train a large language model based on three main parameters. One is the data. And of course, here is not just the amount of data that matters, especially at this stage, because while in the initial point, the amount of data did matter, right now, what matters most is actually the quality of the data. So the curation of the data, the quality of the data. Then the billions of parameters, meaning that once you give it to the large language models a few hyperparameters that it will use throughout the unsupervised pre-training process, then the interesting part, and that's the key element, the AI is going to actually be a pre-training that goes unsupervised, meaning that the AI is going to go back and adjust its parameters to make it, a sort of fit better its objective, which again, it's text-to-text prediction. And then we can argue what's going on when we do this at scale, if there are like other emerging properties, which is something that people in the space love to talk about. But again, that's what's going on. And the other element, as I said, is the unsupervised learning. So for the first time, we could actually do like a pre-training on a massive amount of data by making the model able to actually rely on billions of parameters to get sort of fine-tuned on top of the data that it was fetched into the model to do it in an unsupervised way. And what you get at the end of it on the other side is a sort of file that is going to give you like those billions of parameters, and it's a sort of compressed version of the knowledge that you get. So that's the interesting part. It's not like the AI is necessarily memorizing what sits underneath. It's more like the AI is compressing the knowledge that it's actually going through as it gets the data. So after you put this stuff into the transformer-based architecture at scale, imagine like hundreds of layers of this neural net, that's where you go after through fine-tuning to go from a generalized model to a specialized model like GPT. And then when you want to get something like ChatGPT, where it's actually built to have conversations with humans, then you want to have on top of it another reinforcement learning from human feedback, where you show the AI a few key examples for each vertical that it's interesting as an application, and the AI is going to become also specialized in those elements. Now, going forward, how does, for instance, a business model look like of a company like OpenAI? This is from last year. I did not update it yet, but there are a few other interesting things that come here. But pretty much the interesting part of this AI change right now, this AI paradigm right now, is that not only we're seeing the emergence of a very successful applications, AI applications, like the case of ChatGPT, but on the other side, we also see the emergence of a very strong developer ecosystem through APIs. And right now, of course, ChatGPT is trying to replicate this also via the developer ecosystem made not necessarily of developers, but also content creators. Because, for instance, when OpenAI launches something like custom GPT, what you're trying to do is actually not only to have developers, so people more technical to develop apps like you get at API level, you try to have inside also people that are able to pretty much work by using English commands, so by using natural language commands. So that's the interesting part about this AI paradigm, and I stop here, then I move forward, but that's the key to understand it. Not only we're getting very interesting, a very strong developer ecosystem, we're also seeing the development of strong consumer applications, and we also see the integration of those applications at enterprise level. So the reason why this integration is happening so quick, even though it might take longer than we think, it's not like in a year everything is going to happen, it's going to take more like a decade. But the interesting part is that this integration is happening at all levels: consumer level, developer, community level, and enterprise level. And those three things are working together right now. And the interesting part is that it might have been easier to launch consumer-based products on top of AI than actually enterprise ones, where you want to be way more accurate than just fast. And so that's what's going on. So of course, the way the AI can be structured and the way it's going to work in the future can have different structures. I like a decentralized sort of model for AI, where it does not mean that you're not going to get large players. It means that you're not going to get a single player that controls the whole market. And one example of this that I structure here is that once you got like a strong foundational model, then this strong foundational model can be directly served on a hardware, which can be also your iPhone, or in the future, like AR glasses, which will run AR agents that will be able to perform tasks on the fly for the user. And these generative AI models, which will be able to personalize the experience for the user. In other words, hopefully, the kind of architecture that we're going to get for the AI scale is that we will be able, outside existing models like ChatGPT and products like ChatGPT, we're going to be able also to run locally those generative AI. And we already saw the launch of a few interesting products like Rabbit or Rabbit AI, or like, for instance, other products that are coming up with ideas where you can serve the generative model on the fly through a RAG architecture as well on the device, so that everything is happening on the device. You don't have to call APIs each time, and therefore you don't have to pass relevant data to a single player that controls the whole market, which is what's going on right now with ChatGPT. So hopefully we're going to get to a market where we can have this kind of architecture, but we'll see. And the interesting stuff is that right now we saw the emergence of many new players in the space, which are doing interesting stuff also in terms of hardware, like again, like the AI pin, or the Rabbit AI, or even the glasses that are right now getting launched. I remember the name right now, but I actually ordered one. And then, of course, we have the launch of the Vision Pro, which itself, to be successful, the Apple device is going to need to leverage AI actually to make the AR experience as smooth as possible. Now, going forward, again, the interesting thing is, the ecosystem, when you look at the kind of business model that develops on top of the AI, is that you can have an underlying, you're going to need to have an underlying supercomputer that is going to give you the chance to, first of all, pre-train the model. Because right now, the main drawback of a large language model is that you can still do slight changes on the model, but if you want to do like more fundamental changes on them, you need to go back to pre-training. Of course, there are many companies that right now are making it possible to do important changes, not necessarily on the foundation model, but as we go through the application. For instance, there are like RAG architectures, so retrieved augmented generative architectures that enable the large language model to become quite specialized and tied to a knowledge base thanks to those architectures, and therefore enable us to use a large language models in many verticals. But right now, of course, the main draw, we still need to go back to pre-training if we want to change fundamentally the large language model. And each time that you go back to pre-training at the scale of parameters that we are at right now, at hundreds of billions, it means probably hundreds of millions each time of going through this pre-training. So it gets quite expensive. But anyhow, that's how usually a business model of AI, this current AI paradigm looks like. So you got a supercomputer, you have a large language model, and then on top of it, you have a bunch of applications. Those applications can be integrated into existing B2B or enterprise applications. Like, for instance, take the partnerships that OpenAI has with Microsoft. It can be integrated into the enterprise ecosystem via cloud. This can happen, for instance, through Microsoft Azure, through Amazon AWS, through Google Cloud, through Oracle, and so forth. And then on the other side of the spectrum, you got the whole sort of a consumer ecosystem made of developers that build applications on top of ChatGPT, made of custom GPTs right now, which is the store that OpenAI launched, and all the other apps developed with the OpenAI or Anthropic or Stability or all the other APIs available on the market. And what's going to happen next? I like a lot this graphic that Google shared more, I think, a year and a half back, where it shows that right now what we're looking at is sort of multimodal. And we're already there in some way because, for instance, if you look at a model like GPT-4, you can already plug images and you already got the LLM which interacts with images. But of course, the real multimodality, we're going to get it once those models will be able to really interact at any level, any format with the users and build an application that can do that natively and at foundational layer level. And then on the other side, also quite interesting is that this multimodality can be integrated on hardware so that hardware and software combined become this new AI paradigm where the AI is no longer just optimizing based on the software, but is going down to the hardware level. So again, just to recap, that's how things are looking like right now, where again, on the hardware paradigm, you got the GPU that enables AI companies to do like the pre-training on top of an AI supercomputer. Once you do the pre-training, you go through various stages to get a generalized model, and then you do like fine-tuning, and then use other approaches like reinforcement learning from human feedback to get things like ChatGPT. And at the same time, in terms of business paradigms, you got a foundational layer where you have all the foundational models, be them vertical, be them architectures like RAG architectures that enable an LLM to become specialized on a knowledge base, or be them multimodal, as we're moving forward right now in that direction. Then we have a middle layer where you got very strong vertical enterprise B2B applications able to replicate many functions. Again, imagine here the case of the AI accountant, AI lawyer, AI CFO, Chief Executive Officer, and so forth. So the day when you're going to have those sort of vertical assistants, which can be very powerful for the organization, is going to be the day where the AI ecosystem is really, really strong. And then, of course, the third one is the application layer. When ChatGPT was launched, just 1 month after, I really built this mental model to explain the industry. And I think it's a good mental model to understand the evolution in the coming years, where you get the foundational layer, where you have all the key players. Again, here, it still makes sense to divide them up in text-to-text or diffusion models, but in reality, going forward, we're going to see multimodality combining them all. And the interesting part is that underneath this foundational layer, there is the hardware. So the interesting part is that right now, the whole ecosystem for hardware and new specialized hardware is sprouting up. So we'll see that as foundational as well. And this will become critical because if you have an hardware platform on top of which you can really serve your software, is going to become a huge competitive moat for whoever is going to achieve, good market share on that side. And then you have the middle layer made of specialized vertical applications. So your AI accountant, lawyer, HR, until we get to the point where we have an AI in the next, 20 years, that is going to be like the chief executive officer, or if you wish, the extension of the CEO of the company. And then you have all the other business consumer applications that will be spurring up in any direction at consumer level and be integrated not only into existing players, but also in new ones. And just to be clear, I do think right now that those that will benefit the most from this AI revolution will be the existing players. However, I also think that the native companies within this new paradigm will be the ones that really will create like breakthroughs, meaning that, yes, we'll see companies like Google, Meta, Apple, Amazon, Microsoft taking over the industry, but we'll see also the emergence of new players that might become as big as those companies the next 20, 30 years, because they will be born with this new paradigm and therefore will be native for that. So right now we're seeing the integration of AI applications into the current distribution architecture of the internet, but that's the thing. We'll see also a new kind of distribution layer born just for the AI ecosystem, which will be the one that will give us a glimpse of what's possible with the AI. In short, right now, we just scratched the surface.